abstract classes and abstract methods. And to do that, I am going to go through an example that does not use them and show you why they are useful and how we could use them. And then in the next video, we'll talk about some rules for using the keyword abstract in our classes and methods. So let's take a look at this project that I have here. I have some classes set up. Here's geometric object as a class, and it's going to be some kind of object. We can specify its color. We can specify whether it's filled. So maybe this is for some kind of graphics program. So we might have circles or squares, and we're going to decide what color they are and whether they're filled or whether they're not filled. It's also keeping track of the date the geometric object was created. We have a constructor for the geometric object. We have two constructors for the geometric object. We have a way to get the color, set the color to see if it's filled, or set its filled property. And we can look to see what date it was created. And we have an override of the toString telling us about the geometric object. All right. Then we have the circle class, which inherits. So it extends geometric object. And it has an additional field called radius. And we have a couple constructors for the circle. We have a way to get its radius and to get its area, get its diameter, get its perimeter, and we have a toString. And we also have a rectangle class, very similar, except rather than a radius, it has a width and a height, and it has some constructors. It has a way to get the width and the height, and a way to set the width and the height. It has a get area and a get perimeter. And it also has a toString method. So simple inheritance. We have circle and rectangle that both inherit from geometric object. Let's look at our test program here. We're creating a geometric object. In this line, we're creating a circle object on this line, and we're creating a rectangle object on that line. And when we're done, we're just going to print out those three, and it will use their toString methods to give us information back about those. Let's run it and see what it does. So I have a geometric object that was created today, a circle with this radius, and a rectangle with this height and width. So everything works great. We can create geometric objects, circles, and rectangles. Now, the question is, do we actually want to be able to create a geometric object? Does that make sense? It's pretty nondescript. Do we ever want to create one that isn't a specific type of geometric object? We probably don't. We want to create a circle, or we want to create a rectangle, or maybe later on we make triangle classes or square classes or whatever other classes that will inherit from geometric object, but we don't actually ever want to do this. We don't want to allow people to create a geometric object that isn't a specific type of geometric object, like a circle or a rectangle. So to prevent that, what we can do is in our geometric object class, we can make it an abstract class. So to do that, all we have to do is add the abstract keyword to our class definition. So I'm going to save that. And immediately when I do that, I come over and look at my test case here, and it says geometric object is abstract and cannot be implemented. Now we can no longer create an object of the geometric object class, but we can still use it for inheritance. So circle can still inherit from it. Circle's still going to have a color, and its filled property is going to be true or false. Rectangle can also inherit from the geometric object class, but I just can't create something directly from the geometric object class. It is only there so that other classes like circle and rectangle can inherit from it. So I can no longer do this. And because I can't do that, I'm not going to print anything out about it. Okay, so that's an abstract class. It's a class that's going to serve for other classes to inherit from it, but it itself will never be instantiated as an object. That's pretty simple. So now I can still make a circle, I can still make a rectangle, both of which inherit, and we don't have any problems there. Simply by adding that simple word abstract to the top of the class, we now say this is a class that you can use, but you can't create an object from it. Now let's talk about abstract methods. So down here we have, for any geometric object, we might want to calculate the area. And we have that in circle. We have a get area method. In rectangle, we have a get area method. But the other thing I can do in my geometric object is I can put in an abstract method, public abstract double get area. And notice I didn't put a block of code after it. Okay, I can put this abstract method inside my abstract class, and I don't have to write any code to make it work. Okay, an abstract method requires that any class that inherits from this class must have a get area method. Okay, abstract methods can only exist inside an abstract class. If I tried to do it in a class that wasn't abstract, it wouldn't let me. Okay, so I can create this abstract method inside my abstract class, and that requires now that anything that inherits must have a get area method. So if I go over to the circle class now, and let me highlight this, and I'm going to use the Control/ key. That's a shortcut if you didn't know, that will automatically comment out. Okay, I'm going to save that. And immediately, my circle class has a problem. My circle class has an error that says circle is not abstract, but it does not override the abstract method get area that comes from geometric object. Okay, so the compiler is telling us right now, or actually NetBeans, there's an error here. This is not going to work because I have not done a get area method. I have to add that overridden method get area in geometric object. And if I don't do it, I can't inherit from geometric object. The abstract method in geometric object requires now all of my specific kinds of geometric objects. They must all have a get area method built into them. That's nice to be able. It's nice to be able to enforce this here. That way we know that any geometric object we ever create will have a get area method, which means we can process them all in maybe like a list of geometric objects, and we know that we'll be able to call the get area method because it's enforced. So abstract methods exist in abstract classes. You don't have to write the code for them in the abstract class, but every class that inherits from it must implement that method and must write code for it. There is a small exception to this. If I decided to create another class that inherits, for instance, circle, and I wanted to make circle as an abstract class, I don't, but imagine that I did, then I do not need to implement the get area method. Okay, so you either have to implement it or you have to make it abstract again, which means that whatever inherits from this eventually has to, somewhere down the line, somebody has to write code for the get area method. Okay, so I can have abstract classes inheriting from abstract classes that inherit from abstract classes. None of them have to write it, but the first time I try to write a concrete class that's actually going to be something that we're going to create an object from, that class is going to have to implement it ultimately. All right, so now I want to show something else. I have a little yellow squiggle here. I'm not sure how it shows up on the video, This says add override annotation. Since I had a get area in my circle class, it is now being overriding the get area abstract method from geometric object, but I don't have the override annotation there, so I'm going to just go ahead and add it. And there it is, add override. That cleans up our code a little bit. Probably the same thing happens in the rectangle class. Add the override annotation there. Okay, that wouldn't actually be a compiling error. It would still work, but it's the best way to do it. All right, so that's the basics of abstract classes and abstract methods. Abstract classes are classes that we don't want to actually create objects from. We only want to use them for inheritance. And abstract methods are methods inside an abstract class that we want to force all the classes that inherit from this class must implement the abstract method we defined.